Okay, Tustin. Good afternoon again, everybody. Nice to see so much of you have returned. I'm happy to see you guys here. Right, so how's the audio? Are you all hearing me well?
Yes, sir.
Yes.
All right, very good. So, see, that's good. All right, let me, it's 6 o'clock roughly. Let's begin one time so that we can finish every day today. All right, it's quite a packed afternoon. Let me share my entire screen. So just give me a second to get everything shared and we'll begin shortly. Right. Right. So, right. So I think you all should be seeing my screen. The session has been recorded. Everything is good. That is out of the way. Remember not last week, last day, we stopped on this particular question that I said I wanted to do with you guys. Right? So this is the question we stopped, and I really wanted to do this one with you. Now, I wondered if anybody had attempted it on their own. And if you had attempted it, you would probably see that there's not much to this question. It's not that much of a difficult question, right? So let's do this one together. And again, I would like for you all to switch on your mics and give me active answers. So that way we can progress quickly through the session. So just switch on your mics and answer all questions to the best of your ability. And in doing so, I will know that learning has taken place. So let's begin. We're starting off today with this particular question. The diagram below shows two rectangles M and N with their dimensions expressed in terms of X. Given that the difference between the areas of the two rectangles is 64 centimeters squared, show that x squared minus 2x take away 35 is equal to 0. So it's not that difficult of a question once we get the hang of what we're going to be doing here. The first thing we need to do is find the area of each shape. Right? That's the first thing we should do. We need to find the area of M and find the area of N. So what is the formula we generally use for area of a rectangle?
Line by breadth.
Length by breadth. Length times
Very good. Right? So because of the space and I write them big enough for you all to see, I might just put down this information. But we know length by breadth will basically be this multiplied by this. We don't have nice numbers, we have expressions. So we're going to be multiplying these two expressions. So let's do that. So the first expression was x minus 3, and we need to multiply that by 3x plus 4. So this would be for which shape? M. This would be the area of M. Okay, so let me just write something here. Area of M. This is a classic double bracket expansion question where you have brackets and we have to expand. The same way we encountered something like this yesterday. So what we do in a double bracket expansion, we take the first term in the first bracket and multiply it by everything in the second brackets. Be mindful of your directed numbers. Be mindful of your multiplication of algebraic terms. Those are the two things you need to pay attention to here. So let's get started. You will help me do the multiplication quickly. So what is x multiplied by 3x?
3x.
Very good. You're ready. Right, 3x squared. What is x now multiplied by 4?
4x.
Right, so that'll be positive 4x. Now, moving to this one underneath, what is negative 3 times 3x?
Minus 3x.
Look at it there. So let's do the signs
Minus
first.
9x.
That is correct. But let's look at it. This is a positive. Let me put it in here. This is positive. We have a negative being multiplied by a positive. So our sign is going to be negative. Negative times a positive is negative. Now, what is 3 times 3x? That will just be 3 3s are 9x. Don't let it scare you. It is a simple expansion problem, distributive law. Last one. We have negative 3 being multiplied by positive 4. What is negative 3 multiplied by positive 4? Use your calculators.
Negative 12.
Very good. Minus 12. Let me use the correct color for that. Minus 12. And because I would just want to simplify this a little bit. Are we seeing any like terms in this? Anything alike?
The 4x and the minus 9x.
Very good. Notice when we say like terms, they have the exact same variable. Don't be tempted to think that this is the same. Huh? Why is this one? I put the arrow by here. Why is this not the same as x? Yes,
Because that's x squared.
Doesn't have a square.
Very good. Right, you all know it. I'm happy to see that. That one is x squared. So let us simplify this a little bit before we go any further. So we will end up with what? 3x squared. Now, what is positive 4x? Take away 9x.
X.
Minus 5x. Right? So if you directed numbers off, guys, use your calculators. Positive 4, take away 9, and you'll get negative 5. Don't forget to put back your x. And you put minus 12 here. So this is the area of M. We have to now find the area of N. Okay, so we're going to do both. We found the area of M. And now I'm just running a line of separation. And I'm going to find the area of N now. Using the exact same thing, right? The same method. Area of shape N, capital N. So what, well, is x plus 2 and x minus 3. So again, it's a rectangle, so we multiply the length by the width, basically. So we are just multiplying these two expressions just the same way we did it before. So let's get back into that zone. So I'm going to put down the two expressions. I believe the first one was, well, one was x plus 2. Let me write that a little bigger. No need for it to be so small. X plus 2. And the other one was what? X minus 3. For those who following along, right? These were the two sides of this rectangle N. So again, we're going to distribute using the same method we did before. So let's do it. I'll use this blue color to show the lines. We taken the x and multiply it by the x here first. What would that give us?
X squared.
X squared.
Very good. Now, x times x is x squared, not 2x. That's a common mistake students tend to make, right? X times x is x squared, not 2x. If you make that mistake, be aware of that. What else we multiplying? We're taking the same x, and now we have to multiply it by negative 3. So what is x times negative 3?
Negative 3x.
Very good. So moving on, look at this now. We have positive 2 times x. What does that give?
2x. 2x.
Very good. So remember, if you all switch on your mics as much as possible, because I wouldn't be able to check the messages for the interest of time. So try to use your mics, please, if you can. Right. What is positive 2 multiplied by negative 3? Positive 2 times x.
Negative 6.
Very good. Negative 6. Right. So that's it. We did the expansion. Now we could simplify this a little bit. Can this be simplified? Does it have any like terms?
Yeah. That's it.
Yeah.
These are the like terms. So what would we get here? Can you call out the equation that we will get? Okay, so let me start off. So you'll get the x squared. What is negative 3x add 2x? We need to simplify this. So what?
Minus x.
Negative 1.
Negative 1.
Right, so it'll be negative x or negative 1x, okay? Now, you don't necessarily need to put the 1. You could just put negative x. You don't need to put the 1, but you can put it if you desire. And you cannot forget to write back the negative 6 here. You cannot forget it. So what we did is we have the areas of both shapes. That is very good. But they want us to find the difference. What does difference mean to do? Add, take away, multiply, or divide?
Take away. Take
So,
away.
Very good. So we are going to take away these two things. So I am going to write this here. 3, watch how to take this away. 3x squared minus 5x minus 12. This is the area of the first rectangle. They want us to take it away from the area of the second rectangle. So those of you, let me see. Would I just write it like this? X squared minus x minus 6. Am I good? But is this correct?
No. You put it in brackets.
We
Put them in
have-
brackets.
Right. The most important thing, though, is at least, if you cannot remember too much brackets, put this one in brackets, at least. This is the most important one. You know why this going in brackets for? Because, remember, you are taking away everything here from everything here. Sorry, you are taking away everything in this one from this first expression. If I had not put the brackets, it would have just been take away x squared. But because this is inside the brackets, everything in here is being subtracted from the first expression. It doesn't matter to put the first bracket, but we can still put it if you desire, right? So you can still put it. There's nothing wrong with putting it. So now we have to take away these two expressions. What would you do to take away these expressions? Anyone want to volunteer a solution to how to take away these two expressions? What do you think we need to do
Take
now?
away the like.
Sorry?
Take away the like term.
Very good. We need to take away the like terms. But there's something we should probably do a little bit before we take away the like terms.
Group them first.
Yes, we could group them, but something we could do a little bit before we group them. We could kind of get rid of these brackets we put here. We put them for a particular reason. And the bracket makes a big difference. And you're going to see now the difference the second pair of brackets are making. You're going to see why these brackets are here. So before we could group them, because yes, we're going to eventually group these things, we definitely need to get rid of this bracket here. You'll see why this is important. Now, if I put a 1 here, and I'll use a different color, -1, is that confusing to anybody? Let me know. Switch on your mic. I want to know if you all have this level of intuition. Think about it, because a lot of students get to lose marks at this point. If this was an add, guys, you didn't even need to bother with brackets in this whole question. But because this is a subtract, we have a single bracket expansion taking place here, and we don't even realize it. We need to multiply everything in this bracket by -1. That's the right method of how to get rid of this bracket here. We put the brackets to signify that everything here is being taken away from everything here. That is what we put the brackets for. But because the sign is a takeaway sign, it means that before we could group terms, we need to multiply everything here by -1. If you did not multiply everything in there by -1, you will get the answer, you will get the wrong answer. That is why single bracket and double bracket expansion is very important. Let's see what effect this is going to have on this question. I'm putting back the equation 3x squared minus 5x minus 12 for now. Okay? I'm putting it back there because we didn't touch that as yet. We're just focusing on this portion. What would you think will happen if I multiply -1 by x squared? That is this thing here. Just now, I'm going to get the mouse. I can't even see my mouse. All right. What would happen if I multiply -1 by x squared? What would I get here? -1 times x squared gives me what?
Negative x squared.
Negative x squared, right? So that is what I'm going to put here. I will use a different color. I'll use blue for this portion. Negative x squared. Now let's see what's going to happen to what's the sign in front of this x right now? Negative.
Negative.
What's the sign in front of the 6 right now? Negative. If I take this -1 and I multiply it by this negative x here.
So you get that positive.
You see what happened? Why this was important for? The sign changed. Okay, you see how that was important? And if I take -1 and I multiply it by the -6, what would happen to this -6?
Positive 6.
Very good. And this is a step that many students would leave out and get the whole question wrong, even though you know most of this question. Now that we've done this, we could group our like terms. But there's one thing I forgot to put here. Remember, they told us that the difference between the areas of the two rectangles is 64 centimeters squared. So I could make this now equal to 64. I could also make this equal to 64 because this is the difference we're dealing with now. Now all we need to do is group our like terms. But we could simplify it on the go. We don't really, or do you want me to write it grouped? Let's write it grouped then, okay, for the sake of students. Call out the two x squared terms you are seeing here.
3x squared. Square and x squared.
And x
Right,
squared.
good. Very good. So we have 3x squared. I'm grouping them for now. Minus x squared. What are the x terms we are seeing right now? Pull out the sign in front of them.
Minus
Minus 5.
Mm-hmm.
plus
Minus 5x.
plus x.
Very good. And what other x terms are we seeing? Well, not x terms, sorry. What numbers are we seeing?
Minus
Minus
12 and plus
plus
positive x.
Right, so let's make sure, hoping we don't make any little errors anyway in between my doubt. Right, we've been double checking everything. So far, are we okay?
Yes, sir.
Yes.
Right, so we're not bad as yet, right, with this question. So let's simplify. What is 3x squared take away x squared?
2x
Simplify.
squared. 2x squared.
2x squared. What is minus 5x plus x?
Minus 4x.
Minus 4.
Very good. If your directed numbers are bad, guys, use a calculator. This is just minus 5, add 1, because there's an imaginary 1 in front of that x. And what is... Now, let's look at this. We need to do one thing. Actually, let's continue. What is negative 12 add 6?
Minus 6.
Negative 6.
Equals 64. Now, if we go to the question, now I just need to remove these two green arrows because it's blocking the thing that I need here, these things here, right? This is the equation that they wanted. X squared minus 2x. Take away 35 equals 0. So allow me to write that down some. Okay, you all could look at, you all could see everything on the screen, right? It's not blurry, right? Is this what we got here looking like what they had on top there? Yes or no?
No, sir.
No.
No,
So
sir.
did we do it wrong? Or do we have some more working to do?
More.
A little more working to do. So at this point, students will get discouraged and say, well, I do this whole question wrong. No, you did not. Let's show you how to make it look like this. Notice at the end here, we have 0. How do I get a 0 in the end of mine? What do you think I need to do here?
Make the equation equal to 0 or across
Right.
64.
Very good. So we want to make this equation now equal to 0. So we take in the 64 and we could carry it across, or you could minus 64 from both sides of the equation. Whichever method you all learned, anyone that suits you. But the easier way teachers usually use is just move it across the equal sign. So if we move 64 across the equal sign, what would it become?
Minus
64.
Negative 64, right? So let's just write over everything. Real writing is how to do it. 2x minus 4x minus 6 minus 64 equals 0. Can we simplify this a little bit? Negative 6 take away 64. What is this? Let me fix this 4 because I find it looking like a 9. So it won't confuse anybody. So what is, if we simplify negative 6 take away 64, what would that give us? Very good. 4x minus 70 equals 0. Compare our stuff now. Is it looking identical as yet?
No.
No.
So what do you think we're going to have to do now? Anybody knows?
Divide by 2.
Yes, for those who don't know, that is allowed. Whatever you do to one side of our equation, you can do it to the other side. We are going to divide this side as well as this side of the equation by 2. So that is what we're going to do. Everything is going to be divided by 2. And this is how we're going to get our answer identical to theirs. So what is 2x squared divided by 2?
X squared.
So if you notice, the 2 and 2 will cancel. So all we left with is x squared. What is negative 4x divided by 2 now?
2x.
Negative 2x.
Negative 2x, right? So don't forget your negative. What is negative 70 divided by 2?
Negative 35.
Negative
35.
And what is 0 divided by 2?
0.
0.
Is this what they had now? Let's look at it. Did we get it?
Yeah.
Yeah.
So all of this for 4 marks. Okay? I just tend to write a lot. But It's possible for you to do it without all these steps, but I just tend to put as much work in so that people have things to follow. So are we okay with this one?
So why we divide by 2 again?
The reason why we divide this by 2 is because we want to make this equation that we have in green right above this line look identical to the equation x squared minus 2x minus 35 equals 0. Because they want us to show, right? They want us to show that when you take away the difference of the areas, we get this x squared minus 2x minus 35. But when we took away our areas, we didn't get that. We get 2x squared minus 4x, take away 70 equals 0. So by dividing it by everything in it by 2, we manage to obtain that. And this is something that we do. And in mathematics, we simplified this equation. We kind of reduced it a little more because everything in this equation could have been divided by 2. It's a factor of 2 in a way. So that is it, right? That is the end of this particular question. I wanted to do this yesterday with you, but we wouldn't have finished it. So today, let me tell you the agenda for today. What I want to do is I want to do a question 3, a 4, a 5, and maybe a question 6. If we don't do out the 6, we do that next day. Right, so that is how we're going to be doing a question 3, a 4, and a 5 at least. So by at least today's half of the program, it's a 4-day program, we would have finished half of a long paper. Right, so let's see how much we could get done today. Now, I have made some edits to the document from yesterday. This is the same document I've been working on yesterday. But remember, there were questions we left out. All the questions we left out, I put work in here, and I will re-upload this one for you. Okay, for under session 1, I will remove the other one and re-upload this version. It has the exact working from yesterday. All I did is all the blank questions that I would not get time to do, I put solutions for them. Like these questions, we didn't do them. I have the working for them. You all could try to follow this along. So at least you get some solutions. We did this one. No, we didn't do this one yesterday, but I put the formula and we did the working. Here, we did this one yesterday. We did all of this yesterday. Here, we did this yesterday for sure. We did this yesterday. We did this one today. And this is something we need to do today. Right? I have some stuff to do today here for you. So with that, we're moving on to question 3 now. And let's see how to get a question 3 done. And this is from the 2021 June paper, for those who are interested. And we are starting off with a very, very easy question here. This is what type of triangle are we looking at?
Right angle.
Right. Instantly, what topic should be coming to mind as you see right angles and angles? What topic? Trigonometry. Very
Trigonometry.
good, right? Yeah, excellent. So trigonometry should be coming to mind. Now, this thing here, the diagram below shows triangle PQR, in which angle QPR, so the angle is P, which you can see here is given as 62 degrees, and angle Q is given as 90 degrees, and the line PR is 11 centimeters. They want you to calculate the angle, the size of angle PRQ. That is this missing angle. How can we find this angle? Does anyone? Let's look at the marks. It's a 1 mark. So, what method could we use to get that angle? There are multiple ways we could get that angle, but what is the easiest way you think we could figure out this missing angle R here?
A triangle has 180 degrees.
Sorry. Okay. Yes. Somebody said it, and a girl said something. I didn't hear what she said.
A triangle has 180 degrees.
That is what we're going to be using. A triangle. You should know that the sum of all the internal angles of a triangle. Triangles have 3 angles inside of them. They must all add up to give 180 degrees. Do we know any of the angles inside a triangle? If so, which ones do we know?
P and C.
90.
Very good. So we know P and Q, which is 90 and 62. So if we know 2 of the angles, and we know the total is 180, can we find R? Is it easy?
Yes.
Very easy, right? This one is an easy mark. So let's look at how to do this. So this would just be 180 degrees take away the sum of the other two angles, which is 90 plus 62. This would give you your missing angle. What does this work out to be?
28 degrees.
Right, 28 degrees, right? So things like this I wouldn't use my calculator for, right? So this is good. So that's it for that one. Now they want us to get the length of side RQ. So I'm going to just sketch over the triangle right here so we could work on the triangle right here. So the triangle was a right angle triangle like this. Something like that. This is our right angle. This angle here was given us how much degrees? 62. So I'll just
62 degrees.
right. I just ran an arrow and writing 62 here because I can't make it fit. And this was given us 11 centimeters, I believe. What we want to do is find the length of the side RQ. Where would RQ be? RQ is the bottom of this triangle here. So that is what we want to find. We want to find this missing side down here. Okay? I'm going to call that side X. So I'll use red because you don't need to call it X. But just for making a complete diagram, this is the thing that we want to find, and the stuff in yellow is what they gave us. So everything we need to solve this question is displayed on the screen right now. This is a classical trigonometry question, right? Classical. We are not going to see things right now. In this question, we're not going to see sine rule, cosine rule. If you all don't know what those things are, that is a little more advanced things that you have to know in trigonometry. But you use general sine, cosine, and tan. SOHCAHTOA, as some of you may affectionately call it. So that is the technique we're going to be applying to this question, SOHCAHTOA, which is the most traditional form of trigs that you would be aware of since Form 3, I believe some of you may have been doing that particular topic. Before we could do SOHCAHTOA, there's something that we must do on this triangle. We must label certain things. Does anyone know what we have to label?
The hypotenuse.
Hypotenuse, adjacent.
Very good. So which side is going to be, well, you all should know that this is the hypotenuse. The hypotenuse is the longer side of the triangle, as well as it is opposite the right angle. So if that's the hypotenuse, where is the opposite side of this triangle? The missing by where X is? So this is the opposite side, right? So you can just point from your angle, and the side you point to is your opposite. So this is my opposite. I'm just going to put OPP for opposite. What is the remaining side called?
Adjacent.
Right, and I'm just going to abbreviate it with ADG. Now that we have figured out this is what confused students. They could do this, but the problem lies in which one of the trig identities to pick from. Now, the way we could figure that out is let's look at the information that was given to us here. Which of these sides, the hypotenuse, the adjacent, or the opposite, you think are the two sides here that are of most importance to us? Which of these three sides? Right.
Hypotenuse and the opposite.
Very good. Why is the opposite important? Because this is what we're trying to find. Right? That's the unknown. And why is the hypotenuse important for this question?
Because
that is the one they gave us. So that is how we pick the important sides. We pick the important sides based on the one we want to find, which is the opposite, and the one they gave us, which is the hypotenuse. Now we have three trig identities, but which one of the three trig identities has opposite and hypotenuse?
Sine.
Right? So I heard a cosine there. The actual answer is sine. Okay? Now I wouldn't write out all the identities. I'm pretty sure you all may be familiar with it. But sine of theta is equal to what? Opposite over hypotenuse. This is the identity that has opposite and hypotenuse in it, the only identity that has both. And we already established why we need the opposite and the hypotenuse for this particular question. So now that we have this, it's just to plug in information. So what exactly is theta? We've seen theta here, but what is theta? In this diagram, theta is your angle. Are we talking about the 90-degree angle or the 62-degree angle?
The 62.
Good, because you don't ever put in the 90-degree angle in these calculations. Theta is always this angle. Now, if you wanted, you could have also did this question using here as 28. And you would have changed which is your opposite, your hypotenuse, and your adjacent. There are multiple different methods to get this answer. But we go in with the 62. So this is our theta. So we will write it as sine of 62. And that is equal to the what? Opposite over the hypotenuse. What is the opposite? X. Right? And the hypotenuse was? 11. So this is looking like a typical situation where I must use cross multiplication. And that is what I tend to do. I will make this into a fraction, the sine 62, by putting it over 1. Just to help me cross multiply. I know some of you may have other techniques once you reach a point like this, but I always choose to cross multiply because it never fails. Again, we saw cross multiplication a bit yesterday, but you multiply what's on your numerator by your denominator. So what is x times 1? X. Now, what is sine of 62 times 11? That is basically 11 sine 62, or you could put that into your calculator. This is what you have to put into your calculator. 11 multiplied by sine 62. I'll put the multiplication sign not to confuse anyone. It will be 11 multiplied by sine 62. So if by cross multiplying, I generated this simple equation. X will be equal to 11 multiplied by sine 62. Notice my x is the missing side I want to find. So if I put in 11 times sine 62 in my calculator, I'm going to get my missing side. What is this working out to be? Anyone plug the thing? Now, before I write down the answer, take notice of this, guys. Do you recognize those who do not do add maths? Do you know that your calculators have different settings like degrees, radians, among others? Ensure there's a DEG or a letter D at the top of your calculator somewhere. When in doubt, reset your calculator. You do not want to do these types of questions and your calculator is not in degrees mode. Here, your setting of your calculator may have a bad impact on your answer. All right, so once you're dealing with degrees and stuff, make sure your calculator is set in degrees mode. Make sure it has a DEG to the top or a letter D to the top of your calculator somewhere in your display. That is important. So once your calculator is in the correct mode, put in 11 multiplied by sine 62, and I believe you should get 9 point something. What is it? 9 point what?
9.71.
Right, let's just keep it that simple. 9.71 or 9.7, it doesn't matter. Centimeters. That is the answer. That is the length of the side RQ. Okay, and that's it. This is what I call classical trigonometry. It is very easy and classical. You'll find this one as hard or this one was simple?
Simple.
It's simple, right? So far the questions we encounter in here not that bad. Right, so I did a little work on this question because this app here I'm using don't really have a ruler. So it took me a while to do that drawing. But we'll flip back and forth with this. Let's look at the question and then we'll look at these diagrams here. So let's look at the next question. The diagram below shows 3 triangles, X, Y, and Z on a square grid, right? So this is there's another name for these kind of grids. We call them a Cartesian plane, but let me not go into all them words with you. Right, so we just call it a grid. And in this grid, we have 3 triangles. So instantly, you should be thinking about You know, those things like rotation, transformation, reflections. That is the topic that should be popping into your mind right now. Eh? So let's look at the questions based on this wonderful diagram. The triangle X is mapped onto triangle Y by a reflection. State the equation of the mirror line. Now I will remove these lines, and before I write, I need to put them back because this was very difficult to draw. And you will see why I need that drawing. But let's look at this. We have this triangle X, and it's being mapped onto triangle Y below. And what is the mirror line here? Isn't the mirror line the X-axis? Think about it. This is a mirror reflection of X. Every point is the same distance from the mirror line. Notice this point where the mouse is hovering. Let me use a colored mouse that you always see it. This point here is 2 units from the mirror line. This point is the same 2 units from the mirror line. This point on top here is 1, 2, 3, 4 units from the mirror line. And this point down here is 1, 2, 3, 4 units from the mirror line. So I hope you all agree that this is a reflection we are seeing. The question is, what is the equation of the line of the mirror, this mirror line we are seeing? What is the equation of this mirror line? Now, a lot of students would put x-axis, but that is not the actual answer they would look for here. Do you know that the x-axis, the y-axis, and any horizontal or vertical line you draw on this diagram has an equation, a specific equation for each line? Do you know that? Hello?
Yes.
Right.
Yes, sir.
So before I even explain what is the equation for the x-axis, does anyone know what is the equation for the x-axis? The actual equation for it?
Y equals 0.
Y equals 0.
Right. So
equals 0.
I'm going to explain for those who don't understand, but that is correct. The equation of the x-axis is y equals 0. That is the equation of the x-axis. So, oh my goodness. So just 1 minute. I need to put back my my diagram, which I drew there. Very good. And now I'm going to write y equals 0. Let me explain to you why this has the equation y equals 0. Look at the x-axis carefully here and tell me something. Can you see that this x-axis is cutting the y-axis at 0? You all see that?
Yes.
That is why the equation of that line is y is equal to 0. Because this line cuts the y-axis at 0. Let's say I have a next line, like this one. Now we're taking and draw perfect. What do you think what would be the equation of this one? A line that is horizontal and cuts the y-axis at -5.
Y equals -5.
Y equal -5.
Very good. And if we have a next horizontal line that cuts it at -8, what would be the equation for that line?
Y equals
Very good. So you all see the pattern. Let's look at our next situation. What if we have a horizontal line now that cuts the x-axis at -7? What do you think would be the equation of a horizontal line that cuts the x-axis at 7?
X equals
X equals
X
-7.
equal -7.
X is equal to -7. Now, a lot of students will see a vertical line, and in their minds, they'll be like, but this should be y. You know how the y-axis is the vertical axis? They would wonder why would the equation of this line be not, why isn't it y equals something? Why is it x is equal to -7? Because the thing is, the line cuts the x-axis at -7. So the equation is x is equal to -7. If there's one thing I want you to take away from today's class, is this: how to label these horizontal and vertical lines on a Cartesian plane or on a graph paper like this. Because students take that for granted. I'm pretty sure I have a lot of you here today who may have never seen or heard that before. may have never encountered something like that, or even know that these horizontal lines have equations like that, and they can ask you that in a question. Some of you here might have never ever heard that. So go back into the recording when it's posted. Make sure you study that, okay? Make sure you review that and study it. So we're moving on now to number 2. Describe fully the transformation which maps triangle X onto Z. Let's see what that is. So we have triangle X here. Now again, I'm going to remove my wonderfully drawn lines. I'll put them back when I need to. We're going to look at which transformation would map X onto Z. Okay, so that's the thing we're going to be doing. What could possibly put X onto Z?
It's a rotation.
It is going to be a rotation.
A rotation.
Right, it is going to be a rotation. But you're not going to get your full marks by just saying rotation, because you have to describe this rotation. There are 3 things that you need to put in this description, right? The 3 things that you need to put are the angle of the rotation, okay? And you have to rotate about some particular point. So you need to give them the point of rotation, basically, the point in which everything is rotating around, as well as the angle in which this rotation has made. So rotation gives you a piece of the mark. To get your full marks, you need to describe what rotation we are seeing. And in reality, this one is a little bit difficult to visualize. So I will point it out for you. But anyone want to guess what is the center of rotation in this diagram? Remember, we're just looking at X and Z alone. That's the only 2 we're looking at, X and Z. X here and Z. What do you think is the center of rotation? All right, so let me show you. The actual center of rotation here is going to be the origin. Not always it will be the origin. In this particular question, the center is the origin. And if we rotate, look at this particular point here. I want you to pay attention to this particular point. If we take this point, and this point rotates about that origin, look at what is happening here. So it might be a little difficult to see. But picture X, right? We have to visualize X as being slid along this line until it reaches this point. And to end the rotation, it goes back here. Notice that the shape will collapse to form that shape over there. So the center of rotation is going to be the origin, which is 0, 0. And what angle do you think this made? Look at this shape here. It's actually a circle. What angle are we seeing here?
270 degrees.
So this is a 270-degree rotation. On what direction are we moving? Was this clockwise or anti-clockwise?
Clockwise.
So you see how much things we could include in this description. It's a rotation, but it is a 270-degree rotation in a clockwise direction about the origin 0, 0. So this topic might be a little difficult for me. Again, I'm happy to be bringing awareness to these topics. At least that could happen from our sessions. If you find this is a bit challenging, I would beg you all to review some textbook notes, review your notes on rotations. If you don't understand what I mean by center of rotation, you need to look into that before your exam. So I would just like to remove all of these lines. Hopefully, I could put back my diagram, right? I put it back. And I'm going to write everything I said here for the answer. Do you all remember what I said? It was what type of rotation? It was a rotation, yes. But what type of rotation it was? It was a clockwise rotation or anti-clockwise?
A clockwise.
Right. And how many degrees was the rotation?
270.
So I'm going to put a 270 degree, right? Clockwise rotation, right? About what point?
The
About the origin. And for those who don't know what the origin is, it's the coordinates of the origin is 0, 0. Okay? That last comma does not need to be there. So that is the description that would give you your marks here. So we went into the angle of the rotation, the direction being clockwise or anti-clockwise. We also talked about the center of rotation as well. So that's it for this one. Right, this is 2 marks. It doesn't require you to put too much effort into it. Right, so let's move on to the next 2 last parts of this question now. On the same diagram we just now saw, they want us to do a translation. Okay, translate triangle Y using something called a vector. Now, we didn't talk about vectors yet, so don't get me started on vectors, but let's look at what this vector is soon. Now, I want you all to remember it's -7, 1 for me, because by the time I scroll up, I'm going to forget this. So please remember the vector for me, okay? I'm going to write it down somewhere here so that I will have it. And what shape are we translating? X, Y, or Z. You see, I don't forget. It is triangle Y. So remember, it's triangle Y, and the vector is -7, 1. I'm going to write down those information here. So we're going to do our translation now, and the vector was -7, 1, right? -7, -7, 1. This is our vector, and we are translating it. Which shape we are translating? Y. So let's put down that there for me, right? So we're good. What does this? What is this here? What is this? It's a vector, but do you know that this is called a column vector? Have anyone ever heard of a column vector before?
Yes, sir.
Yes, sir.
Why is it a column vector? Because it is written as if it was written in a column. So if you have a table like this, right? It's a table. Your rows just go horizontal and your columns just go vertical. So these numbers, because they are vertical, one on top of each other, it's like a column. And for that reason, we kind of call it a column vector. Right, so this column vector, now just give me a second. I think I had screenshot something here to help you all with understanding column vectors a little bit. So mind this information a little bit, right? So I'm going to put the column vector down here somewhere. It was -7. Why am I writing 7 like that for? -7, 1. These numbers mean something. The sign in front of the numbers means something. Okay? So it's not just that the number is important. The sign in front of the numbers are also equally important. What sign is in front of the 1?
It is positive.
Positive. Right. So do you know that these signs helps us to navigate on that grid? And the thing is that I'll mention to you is the first number here tells us something called the X. It helps us to move along the X direction. And the second number helps us to move along the Y direction. So if we have this object and they say to move on the X direction, I could move like this. I could slide it left or right. If they tell me to move in the Y direction, I could slide it up or down. You all realize that? That is what the X and Y position is. So let me write out, this is X, this is Y. Now, if you look at the X position, notice you could go in 2 different directions. Similarly, in the Y direction, you could go either up or down. So there are 2 directions. Do you know that the signs, being negative or positive, is what indicates which direction you are moving? For example,
Yes,
very
Yes.
good. For example, what would a negative sign, negative X sign, what direction would that point? Left or right?
To the left.
It's negative X.
Left.
Left. Very good. What would a positive X mean? What direction?
Right.
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 Good. What would a positive Y direction be?
Up.
Up. And a negative Y direction would therefore be
Down.
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 So we have a coordinate system here in place that we could move our shape based on this vector. This vector is giving us all the information we need to relocate our shape, to shift it up or down, left or right, based on the information here. So I'm going to save this and I'll upload this for you as well, right? It's just a photograph I took from the net, but I'll upload this for you. Let's go back to our question just now. Why is it looking like that? Okay, let's go back to our question. So -7, what would that mean now to us? We are moving 7 places to the what direction? To the left. And +1 means we are moving 1 place in which direction?
Right.
Up, because this is the y one below. The top one is x, the bottom one is y. So the bottom number being +1 would mean we are moving 1 place to the up. Well, 1 place up. So we are sliding our shape 7 places left and 1 place up. That is what we're going to be doing to this triangle y. Right? So where's my triangle y? Here. So remember, we're moving every point in this thing 7 places to the left and 1 place up. So let's see if you all could help me do this. Now, I don't have straight line access with this to draw straight lines, so it will probably be a sketch. All right, so let's move every point 7 places to the right. Sorry, to the left. 7 places to the left. So if we look at this point here, now I have to increase the size of the point. Right. So we're moving it 7 places to the left. So we're going 1, 2, 3, 4, 5, 6, 7. You all agree with that? But
Yes,
we
yes,
also need to go
Yes,
1
sir.
place up as well. So we're translating every point 7 places to the right and 1 place up. Next point is this one here. We're going 7 to the left and 1 up. So let's start. 1, 2, 3, 4, 5, 6, 7 to the left. Sorry, if I said right, I meant left. And 1 place up would be here. Similarly, this bottom point, we're moving 7 to the left and 1 up. 1, 2, 3, 4, 5, 6, 7 to the left and 1 up. So if we were to connect these lines, which I might not do a pretty good job at doing it, because I just using my hand on a sliding screen here. It's a touch screen. Our triangle would be here. Not that bad. So this is where our triangle is going to move to after we translate it along a -7, 1 column vector. And I think they told us to name this triangle. Did they tell us to name it?
Yes.
Label this image as V. So we have to label the image as V. Is that difficult? Hopefully it's not too difficult, right? Right, so thank you. Now, last question for 2 marks on the same graph paper we've been working on all the time. Enlarge triangle X about the center and scale factor half and label that W. This one might be confusing for students. This is an enlargement question. And every time you deal with an enlargement, we need to look at 2 things. Something called a scale factor and a center of enlargement. So let me direct you to what that is. I already prepared that on this diagram. I tried my best to draw straight lines. What does a scale factor? The easiest thing to understand for now is the scale factor of a half. Let me demonstrate. If I have this box here, I'm just drawing a box, and I have a scale factor. I'll just use an SF, and I scale in this box up by, let's say, 2. If I use a scale factor of 2, ignore this for now. Let's look at my drawing. A scale factor of 2. And it's an enlargement kind of question. If we have a scale factor that is 2, do you expect this object to be bigger, or would it be smaller? If the scale factor is 2. Yes,
Bigger.
because 2 means we are doubling the size. So the box would get, well, that's a little too big, but you kind of get the idea. The box is going to increase in size. So if we have a scale factor of a half, what do you think? Would the box be getting bigger or smaller?
Smaller.
It's going to diminish in size. So this would be half the size of the original image. So we have to instantly know that in our question, after we do this enlargement, even though the question, they say to enlarge, it doesn't necessarily mean that your image, the object is the original shape and the image is what you draw. That is what image means. Image is what you're going to draw. Just because the question has the word enlarge does not mean that the image is going to be bigger. The image can actually be smaller. And indeed, because our question has a half as a scale factor, we have to expect our shape to be smaller. And that is why this center of enlargement comes into play. Because I can enlarge this box, and I could draw a bigger box here, or I could draw this box here. A box anywhere. Where does the box end? Where would we put it on the graph paper? You can see we could put it here too. That is why we have something called a center of enlargement, because that kind of limits the shape to a certain part of your graph paper. That is why we have the center here. This is going to tell us where on the graph paper we're going to do this drawing. The half telling us that the drawing is going to be smaller. Are we clear on that? The center here is telling us where it's going to be located, and the half telling us that it is going to be smaller than the actual triangle X. That's the triangle we are looking at. So let's look at the triangle X on the diagram. I already prepared this one for you. We are kind of already here. So let's look at it. This is how we're going to look. They told us that the center of enlargement is the origin, 0, 0, that is here. What that means, ignore the red triangle, so I'm going to erase the red triangle for now. What that center of enlargement means is that these lines here are basically the working you use to figure out your answers. If I kind of draw straight, it's not that straight. These are free-handed lines, but ideally, these lines should be straight and drawn with a ruler. And you would realize that it starts from the center and it cuts the shape at the corners. That is very important. We have a corner here as well. So I'm going to do one more of the blue lines to show you. I kind of draw it to cover all the corners. Once we do that, right, actually I'll have to erase that because I need to put back my red drawing. Right, so once we draw the blue line, the next thing you do is figure out where you put in your image. So if I enlarge it, I would have drawn my triangle somewhere higher up. Now, the graph paper doesn't allow. Now, I'm trying to draw it as neat as possible. It's supposed to be on the axis itself. Right? If I were to enlarge in this diagram, my triangle would have been somewhere up here. Right? It could have been, but you see, it kind of went out the paper. I wouldn't be able to really get it perfect. But an enlarged version of this triangle might have been somewhere out here. You all see how it kind of get big like that? But because it's the scale factor is a half, that means that the sides, how much squares does this side, how much squares does this side here cut through? Can you see it cutting through 2 of these squares?
2.
So where I am going to figure out where I'm drawing my shape is where this side cuts it at only 1 square. So can you see down here cutting it at only 1 square?
Yes, sir.
That is where I put down that line. Now that I put down that line, I could ground my image. Let's look at the base now. How much squares are the base? 1, 2, 3, 4, 5, 6. So how much, if I'm reducing my shape by a half, my image should have only 3 squares on the base. Look at it. 1, 2, 3. 3 squares on the base. So you notice everything is reducing by a half. And then, obviously, you just connect these lines now, right? So I just connected these lines. And this is my image after my my enlargement by a scale factor of a half. Now, I know that this question can be rather confusing, but it's not that bad once you get practice. So I want you to practice with this question here, right? So this is the end of this paper. This was the end of the question. After we finish the enlargement, we need to label it as W. Let me label it as W before we move on. And I want to show you, I'm just going to show you something. All right, so this is W. Right, so you label it as W and that's it. There was another question on the paper, right? And I put the answers for it already for you. So this is the next question here, the last question on the paper. And I want you to just look at this enlargement here. The original shape is P. I'm not going to show you the question. Let's just look at what happened here. You had to kind of figure out, they gave you the image and the object. Let me get a pointer that works well. So they give you the image, the object P, and they told you the image is S. And they asked you to describe what process maps P onto S. So you should be able to instantly see that S is a bigger version of P. So obviously, S is an enlargement, right? That's the relationship between P and S. You could easily calculate the scale factor by looking at how much each line increases by. Here we have a thickness of 1. Here we have a thickness of 2. So that means we have been doubling the shape. So this shape below is 2 times the size of the one above, meaning that the scale factor is going to be what number? If we double in it, the scale factor is
2.
2. So you'll get marks for saying it's an enlargement. You'll get marks for saying the scale factor is 2. But you also have to give them the center of enlargement. And that is why I know I'm projecting all my lines to meet at a point. Right? If anyone has any questions, just ask. I'm just demonstrating this for you. So I draw straight lines from the tip to this tip and continued my line. From this tip here to this tip here, and I continued my line. From this tip here to this corresponding tip, and I continued my line. From this tip to this tip, and I continued my line. From this corner down in the nook here to this corner in the nook here, I make sure this lines touched both of these and went. Notice all my lines converged at this coordinate 7, 11. So that is how I figured out the center of enlargement is going to be 7, 11. This is a question I want you all to try. I have the answers up already here for you. I answered it for you, but I want you to try the same question again. Right? So remember, I'm not going to do this one with you. I'm going to upload the solution for this question tonight, but I want you to try it on your own still. There are other parts of the questions that I'm not going to explain now. You could try it. You have to try to figure it out. The answers are here, right? But it's available. So this is one I want you all to try. But I hope this gives you an image of what an enlargement question would entail. You need to give the scale factor, which is 2 in this case, and the center of enlargement by projecting your lines back to a point and figuring out what is the coordinates of this particular point. So if you know these things are a little tricky for you right now, this is a topic that you should certainly be refreshing for your exam. This topic. Don't take this topic of this type of geometry for granted. These enlargement, mirror, reflection, rotations, don't take them for granted, guys, because it can be easy marks, but it could also be easy marks lost if you don't take it seriously. So this is how a typical question tree comes in your paper. This is how a question tree looks. Now that I've done this paper, I'm going to upload everything here for you on the course shell at the end of the session. This brings me on now to some new content that I have to upload as well. So let me open that. I hope you all are okay right now, right? I hope everyone is okay. I'm not moving as fast-paced as yesterday, but right, I'll upload this for you as well. I'll upload this for you. This explains the column vector with the drawing we made. I thought I saved it already. All right, so I'm just closing stuff so that the computer won't stick. So this is like a little minute intermission. I've seen you all having your discussions going on. That's fine. right? I can't get to access everything. Let me open my let me open the content for today's class. I don't want to keep too much documents open because it could
Somebody
really...
wanted to know why you connected by top and not by the zero.
Why I connected by the top and not by the zero is where the lines met. Wait for the second one or the first one? It has to be the second one they're talking about. Right, let me just show you. Because it was impossible to connect it to the origin in that case. That is the reality of it. It's physically impossible. And I'll see, let the document open and I will show you again, right? Which one is that? One. All right, so let it take its time. All right, so this is what we're going to be. Is this it? Yeah, this is what we just did. Right, so let me show you. It would be impossible to connect this to the origin. The origin is down here. How are we going to draw a line that touches, let's look at this corner here. Let's use red. We are connecting corners to corners. That is all we are doing, huh? Like this pointy corner here, we have to draw a line that connects these two corners. Notice that line could only be this line. You're getting the idea? It cannot go to the origin. Similarly, I look at this pointy corner here and this pointy corner here. I want to draw a line that connects these two corners as well. So that line would be, I'm not using a ruler, that line would kind of go like this. So you kind of get the idea of what I'm doing there? I am joining my corners of importance. And that is how I could get my center of enlargement. Right? So hopefully that clarifies that a little bit. So I want to close this document again. And I want us to move on to some new content. A question 4. How question 4 looks in the paper now, right? So let's look at a question 4. And this is that is not the one I will use. So yes, the 2 no solutions, right? This is it. Right? So this is the question 4 paper. So let's look at how to do this particular question. Now, a question 4 has to do with, it's basically a continuation of geometry, but you have to deal with equation of a line. You all remember what is the general form of the equation of a line? You would have probably done that in lower form a little bit. That is something called, anyone knows what is the equation of a line? Before I even go into this?
Y equals x plus c.
Very good. Y equals mx plus c. So these types of questions use that concept of y is equal to mx plus c. Let's read this question and see how easy coordinate geometry can be in a question like this. All right, so let's look at how a number 4 looks. If we've worked number 4 till 7:30, and we do number 5 till 8 o'clock, that would be good. Okay, we would finish half of our paper. Our paper is 10 questions. Today is the end of the second day. If we could finish half the paper at least by today, that is good time, right? So let's see if we could do a number 4 and a number 5 before the time ups. Well, 10 finishes. All right, so the first thing we're going to do in this particular question, let's do like if we now seen it for the first time. Let's read it. The diagram below shows 2 lines, L1 and L2. So notice we have this line here. This is L1. And this one up here is L2. The equation of line L1 is, and they give you, x plus 2y equals 10. So that is the equation of this line, and they put it actually on the diagram for you conveniently. X plus 2y equals 10. The line L2, this is this line here, passes through the point 0, -5, right? That's our point here, and is perpendicular to line L1. So L2 is perpendicular to L1. That is very important information that we need in this particular question. So if I write this symbol, what does this symbol mean? Anyone knows what a symbol that looks like that means?
Is that 90 degrees?
That's a
90 degrees.
angle, right? So that just means that these two lines are perpendicular to each other. Okay, we good with this? Everybody should at least recognize that these lines are right angled to each other. Now that we got that out of the way, it's not a difficult question to visualize because they gave us the graph that helps a lot. Let's look at what they want us to find first. They are going to guide us with this particular question. Part 1, express the equation of line 1 in the form y equals to mx plus c that you all had correctly described earlier as the equation of a line, right? So this is the general form of the equation of a line. They gave it to you here, so that's great. But this is not looking like that. I'm going to write this equation down here for us. This equation is x plus 2y equals 10. Let's just write it and look at it. I'm going to write it here. X plus 2y equals 10. Was it 10? X plus 2y equals 10. Yeah? Okay. Is these equations looking identical to each other? Look at this one on top. Look at the one below. Are they in the same way already? What's funny about these two equations? They are not in the same form. In the first equation, what is the subject of that first equation? What do it? Y.
Y.
Subject is what's alone by itself on one side of the equal sign. And what is the subject of the other equation? 10. So instantly, we are seeing that we have some rearranging to do. Okay, you're seeing that, right? Let me make sure this is x add 2y equals 10, right? That's what I wrote here. So we have to rearrange this equation to look like this one. So what that means is we want to make, and I'm going to remove this y and write it in a different color. We want to make this y the subject of the equation. You all understand so far? That is what we want to do, right? We want to make the y the subject of the equation. So how do we go about doing that?
Excuse, sir.
Hmm?
I think someone has a question because I see they keep raising their hand.
There is in the hand. Yeah, you could switch on your mic. I'm begging you all to switch on your mic because I won't want to keep flipping back. I'm going to the chat. If you have a question, now's the time. Post it, right? If whoever posts the question, guys, just try to read the question and let me know it, right? If in case the person cannot use their mic. All right, I'm gonna go back for now. Okay?
Yes.
Just let me know when they post the question. Right. So what I'm saying with this particular question is that in order to get it to look like this, we need to make y the subject of the formula. Do we agree with that?
Yes, sir.
Right.
Yes, sir.
Yes.
Right. So how do we make y the subject of this formula? It's
So
really
you could
easy.
transpose.
We have to transpose the formula. We could do some rearranging. Now, what's the easiest thing? Now, remember, the goal is to get y by itself. But we have other things with y. All of this needs to go. What's the easiest thing right now to move across?
The 10.
Editing.
The actual thing is, we see how we have y here already on this side. I'm going to keep y on this side, and I'm going to move all of these other things across. That's the goal here. So we're going to get the x and the 2 away from the y. So we want to free up the y from this x and this 2. So right now for me, this is a positive x, bear that in mind. But the easiest thing to get rid of right now is this x.
Yes,
I
sir.
can simply move the x across.
Minus x.
and it
Minus
becomes
X.
very good. Right, so, and you won't see it for now, but I'm going to put this minus x in front of the 10. You will see why I do it very soon, right? So regardless, we're going to have 2y here now. I'll put the y in red just for the sake of colors, right? We have colors to work with. And that will be equal to 10, right? 10 No, I want to put the x minus x first. So we agree that the x moves across, it becomes minus x, right? We agree with that? The sign changes.
Yeah.
And,
Yes, sir.
and this 10 is still positive 10. Nothing happened to that positive 10. But you will see, yes?
Why putting, wouldn't the 10 just stay with positives?
Yeah, the 10
Then
moving.
it would-
The 10, actually, we could leave it. Let's leave it like that. It doesn't matter. Yeah. The 10 is still on the left, the right side of the equation. I could put the x in between. I could put it after. It wouldn't change anything. But I chose to put it over here, but we could go ahead and put it in the end over there, right? So we could leave it like that. That's totally fine as well. Okay. So anyway, I just wanted to show you that we could put the x anyway on the right side of the equation. We okay with this now? You better like this? It's clearer like this?
Yes, sir, Tom.
Right, no problem. Right? You will see why I did it eventually, yeah? Because we'll have a little more work to do coming down to the end because we put it here. But you'll see what I mean. All right, so let's continue. So we got rid of the x. What else do we need to get rid of from the left side of the equation?
Two.
How do we get rid of that?
Divide by 2.
So we divide everything by 2. Very good. So I'm going to divide everything by 2. So what is 2y divided by 2?
It'd just be y.
Why?
Very good. We got y equals, let me use back green. Sorry. All right. So again, a little glitch issue here at my tablet, right? So let us bear with it, please. What is 10 divided by 2? That's this here. 10 divided by 5. 5. And would it be too difficult if I put this? Look at this negative x over 2. Would this be too confusing? Let me know if this is confusing to you. If I write it as negative a half x, is that going to be confusing to you all?
Yeah.
Or do I need to show you? Yes. Okay.
No.
Let me show. No. Yes. Yes.
No.
All right, but I think somebody said yes. So let me show you how this. So I'm going to circle it in this color. This is the exact same as this. And I'm going to show you why. We're going to start with this one and work our way back to the top. So let's see. Yeah? Let's see. I'm putting it on the side here for now. I'll erase it after. So I'm going to put with negative a half x. X. Isn't this the same as negative a half multiplied by x? Which is the same as negative a half multiplied by x over 1. If I multiply my numerators, negative 1 times x is negative x. 2 times 1 is 2.
2.
So you see that what's below is exactly what we have on top. Okay? Hopefully, this is just mathematical techniques that you need to develop to help you speed up your work in the exam. But what's negative a half x? Just think about it. In dividing something by 2 is the same as multiplying by a half.
Yeah.
Think about that, guys.
Sir.
If you divide them by 2, and that's the same as multiplying by a half.
Yes, sir.
Yeah. So that's like what we do in here, right? So I can erase these two circles now. Now, the only thing is we need to write this in the form y is equal to mx plus c. Let's see how close we are right now. I'm going to write y is equal to mx plus c below. Y is equal to mx plus c. You all saw why earlier I put the x in front, because in the general form, the x is in front of the number. That is why earlier I chose to put the x in between, so that it would have been already in the form. But that's not a problem. All we need to do is just flip these things around. But because we are not moving, we wouldn't be moving anything across the equal sign. No signs will change. Again, the only time a sign changes is when we move something physically across the equal sign. If we are rearranging things on one side of the equal sign, no signs will change. And that is what we have to do now. So let's make this into the form of y is equal to mx plus c. So y would be equal to, so what would mx be? Wouldn't that be negative a half x?
Minus
This is
Yes, sir.
right. So that will be our mx. Negative a half x. And our
Plus
plus
five.
c would be our
5.
plus 5. Very good. So that is our answer. So hopefully you see why I had chose initially. I wanted to stick the x over here. It would have avoided us having to rearrange it a little bit later on. But that's okay. That's fine. This year, all we did in this question, guys, is we rearranged the equation they gave us on the line into this form. We just rearranged. That's all we did. That's all we did. Using this information now, okay, look at the letters Y, M, X plus C. What does the M means? Anyone knows what the letter
The
M means?
gradient.
The gradient. And what does it means? The C. Anyone knows what the C means?
So line intercept.
Y
The y-intercept. Very good. So the letters M and C are very important, and we'll be using those things coming to the end of the question. So let's look at, they want us to state the gradient of line 1. This is line 1. So what is the gradient looking at this equation? What is the gradient?
Negative a half.
Very good. Right? So that's an easy mark you get for doing your correct transposition, negative a half. So that's your gradient. Everybody okay so far?
Yes, sir.
It's nothing too complex. I'm moving as slow as I can. I can't move as slow as I want to. It's the slowest that I can move. Okay. Let's look at something that we didn't spend any time on before. Let's look at the fact that these lines are perpendicular to each other. We didn't get to spend time on that before. I'm going to draw something here, and hopefully I would be able to, I won't remove it. So these lines are perpendicular to each other. Do we agree? It's not perfect, but it should resemble perpendicular lines.
Yeah.
I want to give you a rule of thumb. For perpendicular lines, if this line here has a gradient of m, a line that is perpendicular to that has a gradient that will be considered something called the negative reciprocal of the gradient m. That just means that whatever the sign is, we flip it. So if the sign is positive, this line would have a negative gradient. If this is m, and we flip, and m is m over 1, that's m over 1 is m. So we flip it to become 1 over m. This is a rule for perpendicular lines. If we know the gradient of a line, we could easily figure out the gradient of a perpendicular line by flipping the gradient we know and changing the sign. Did anybody here ever heard of this before? Or is this new? This is new to some of you?
Yeah.
Now, this is very important that you also see how beneficial this is now to us, that you all are, how you all lucky to be attending these classes. This is something that is part of your syllabus, but is very obscure in your syllabus, right? Our math students tend to benefit most from this, but you see general math students, we tend to not include it in teaching. Thankfully, we do, right, in these classes, and that is why I picked this question. This is look at it. It's a recent question, huh? So they expect that you should be able to do these things. So what I have done here is I showed you a rule for perpendicular lines. Let me just take a minute to show you something else. Parallel lines. Do you know what parallel lines are?
Yes, sir. Only in the
Parallel
same
lines,
direction, but never meet.
Very good. They never meet each other. What is the gradient? Let's say the gradient of this line is m. Because they are parallel lines, they will both have the same gradient, right? So that is one you may have heard of. Parallel lines have the same gradient. But perpendicular lines, look at the relationship of the gradient here. If one is m, so I'm going to erase the arrows. If this one is m, the gradient of the other one will be you change the sign and you flip the number. And that is what we're going to use in this particular question. So if we go now to the next part of the question, they want us to, this is the last part, right? They want us to determine the equation of line 2. So what is line 2? That is this line here. They want us to determine the equation of this line. Did they give us the equation? No, we need to figure it out. So how do
Sir, that means you're going to have x.
Right. Yeah, we have.
minus
Mm-hmm. Mm-hmm.
minus a half equals 0. No.
I'm not too sure, but as yet, right? Because this is the first time I'm actually doing this particular question. I actually know I did this one already, but I can't remember it offhand. So let's work it together, right? It'll be easy. I promise you all. Mm-hmm.
I have a question. Wouldn't line
Mm-hmm.
L2 be the negative reciprocal of line 1?
Yes.
L1, sorry.
The gradient would be.
Yeah.
Very good. And that is the hint here. That is why they wanted you to find the gradient of L1. So they could use the negative reciprocal of L1 to find the gradient of L2, which is needed for the equation of L2. So let's start assembling the equation of L2. In order to know the equation of a line, we have the equation of a line is always in the form of y is equal to mx plus c. We need two pieces of information to find the gradient. Okay? We need to, I cannot say much more questions. We have to do in this one. We have two things to do again. We have some, let's work at this pace. I want us to understand. I don't want us to rush anything. I want us to understand what we're doing. Whatever we get done, at least you would have understood it. Right, so in order to get the gradient of line L2, we need two things. We need the gradient of L2 and the y-intercept. You all agree with that? That's the two things we need. The gradient and the y-intercept. How can we find the gradient of L2? We know that L2 is perpendicular to L1, and we know the gradient of L1. So what we're going to do is write down, well, I'm going to write it here. The gradient is M.
Here, could I write down the coordinates?
Just now, what did you say there? M for line 2. To find M for line 2, we need to find the negative reciprocal of line 1. So let's just do it right here. Negative reciprocal means I hope that's the term they use, but that's what I always call it, right? So if other people looking and have a different name, I apologize for that. It's basically what you're doing. Yes?
It wouldn't. Do what?
Let's do it together. What would be the negative reciprocal of this? So very, very good. Somebody said it. Now let's look how to do it. Negative reciprocal means we are changing the sign and flipping the number. So if the sign is negative, our answer has to be positive.
Positive.
Okay? And if we flip 1 over 2, we're going to get 2 over 1. Isn't that just 2? Positive 2 over 1 is 2. So the gradient of line 2 is going to be 2.
So,
yes?
Stupid question, right? Why are we flipping it again?
That's the rule we follow, right?
Oh, okay.
So that's it here. This is the rule. If the one of the line has a gradient of m, the other line, the perpendicular line to it, has all you do to get the gradient of that is you flip this m and you change the sign. So that's just part of the rule. Okay, you just need to remember the rule for that one. Right, so that's just a rule you need to remember for this particular question. So we now have found the gradient of line 2. You all agree? Easy. Remember, this is a 2-mark question. They're not expecting you to do too much maths here. Right? So as somebody pointed out yesterday for a particular question already. So that's the gradient of line 2. Now we need to figure out the y-intercept, because we conveniently never focused on C as yet. Let's look at y-intercept now. So I'm going to write C for line 2. Let's look at how to find the y-intercept of line 2, and we do it by, but look at this. They give us the coordinates where this line cut in the y-axis. So we don't even have to do any calculations. This is the x coordinate of this is the y coordinate. Where does this line 2 cut the y-axis? Can you all see that line 2 cuts the y-axis at -5? Are you all seeing that? So the y-intercept is going to be -5. Just so, that's it. So let's assemble the equation of the line. Y will be equal to M is 2, so it'll be 2x. And instead of plus c, we're going to put minus 5. That's the equation of the line 2. And that's a wrap for this portion of the question. Are we okay with this one? I took my time with it. Yeah?
I have one question.
Yeah, no problem.
It have any way you could calculate like the equation for it without them giving us, like if they didn't give it to us? It have any way you could calculate that?
No, they have to get all the information for this question must be given exactly the way it is for us to get this answer.
Okay.
They wouldn't be able to trick you up with this one. They have to give you everything like this. Okay,
thanks, sir.
Yeah. All right, so let's move on to part B, which is we have it's 7:30. We'll power through, right? We'll see how much in number 5 we can get done today. So in part B, let's see if we could do this one a little faster, guys. Only because I want us to this one easy in my opinion. This is functions. I'm pretty sure not much people would have probably seen this type of question before. That's why it took some time. But I'm sure everybody here has seen functions already, right? Come on, functions. That's something that I believe you all should have at least some practice on.
Yes.
So, right,
Yes,
so let's see if we could power through
sir.
this one a little quickly. So given that f of x is equal to 1/3 x plus 4, and g of x is equal to this wonderful algebraic expression here, 3x over x plus 1, let us find the value of f of 9. Okay, let's see if we could do it. What we're doing, let me explain in case all you're doing is
Right.
yeah,
Function, and then
Wait,
substitute 9 for x.
very good. That is all you're doing. You substitute 9 for x. So I want you all to take your calculators out and start calculating for me. So when I write it out, I have an answer to put in. So I'm going to start by writing what f of x is. F of x is 1/3 x plus 4. Therefore, 3 dots means therefore, f of 9, you don't need to put the dots. F of 9 would be, wherever I have the x, I have to replace it with a 9. Sorry, 1/3. So instead of x, I'm putting 9 plus 4. 1/3 and 9 is 3, right? 3 plus,
3 plus
4.
4 equals 7.
3
So
plus
f
4
of 9. F of
Very
9
good.
equals 7.
So that's the answer for this one, right? We okay? Simple, straightforward. We substituted 9 for x. We solve for our answer. Next question that require a little more work. They want us to find f of g of negative 3. What does this mean? There are 2 ways you could do this question. One way requires a lot more work than the other. So for the interest of time, you could combine the 2, but that one might take the work in. The easier way to handle this
This
question,
is a composite fact.
yes, this is composite functions. The
Sure.
easiest way to handle this is firstly, now hear this, if you don't trust me, try it the other way. It will work. Trust me. I'm going with the fastest method for this question. The fastest way to do this is first finding g of 3, and the answer we get, we substitute it into f. Has everyone ever did that method?
Yes, sir.
yes, sir.
Yes, sir.
That's the fastest method. Right? That's the fastest way to do this. If you all should know there are multiple ways to do this, that's the fastest method. So let's find g of negative 3. So we want to find g of negative 3. But what was g of x? Let's write it down first. 3x over x plus 1. So g of x is equal to 3x over x plus 1, right? Provided that I didn't write it down wrongly, it is that 3, let me double check that. 3x over x plus 1, right? That's what g of x is. So g of negative 3, what we're doing is we substitute a negative 3 there. So that will be 3 times negative 3 over, where x is, we put in negative 3 plus 1. What would this work out to be? Anyone has that answer?
Negative 9 over negative 2.
Yes, sir.
Very good. Negative 9 over negative 2. And isn't that these negatives could cancel? Because a negative divided by a negative is a positive. So this answer is the same as positive 9 over 2 as well. Okay? 9 over 2 is the answer for this one. So we found, yeah?
Sorry, if you leave it as a negative, you'd still get correct or you get it wrong?
No, you would get it correct, but you have to make sure you put the negatives on both. You can't put negative on one alone and forget the other negative. Follow?
Okay. Yeah.
You had to put negatives on both. Right? But get in the habit, once you have a negative on top and bottom, the whole number is positive automatically because a negative divided by a negative is always a positive. That's one of the basic rules there. So keep that in mind, right? No, that yes.
What if you leave it as 4.5? Would that be incorrect?
No, that would be correct as well. Right? You could leave it as a decimal fraction. Anything, you all could keep it as, right? That's perfectly fine as well. Right? So that's great. What's the next thing we need to do now? Now that we figured out what is g of, remember, we found out what is g of negative 3. That is the latter part. We need to, now all we need to do, let me show you it, is, and I'll use different colors for this. We want to find f of g of negative 3. That's what we want to find. But now we know what g of negative 3 is. So all we're going to do now is basically be finding f of what? 9 over 2.
No, 9 over 2.
9 over 2. That's what we have to do. Right, so that's what we're going to find. So we need to write down what f is, again, f of x, and go back to the process. F of x is equal to what? 1/3 x plus 4. So you write it down. 1/3 x plus 4. So how are we going to find f of 9 over 2? We're going to input 9 over 2 where we have x.
You put it where the x is.
Very good. What does this work out to be on a calculator?
You're 5.5.
5.5.
5.5, and that's your answer. Okay, that's it. Right? That's your answer for that one. It's not that bad. This would have been my 2 marks, I believe most of you could get. All right, I'm moving on quickly to number 3. If you have questions, just let me know. Quickly to number 3 now. This one, I don't know how much of you might be familiar with number 3, but they want you to find a value for x.
Yes, sir.
In which the g of x is equal to 512. So let us start by writing what g of x is first, because that is what they have in the question. G of x is equal to our initial formula for it, 3x over x plus 1. So I'm going to put that here as 3x all over x plus 1. Okay? But, and they tell us that gx is equal to 5 over 2. So I'm going to replace gx now with 5 over 2. So 5 over 2 is equal to 3x over x plus 1. You're seeing and understanding? I just replaced g of x with 5 over 2 because they told us that is what it is. All we need to do now is solve for x in this equation, and we can cross multiply. Let's cross multiply together. We multiply the 5 by the x plus 1, right? So that's what we're doing here. 5 times the x plus 1. So that looks like this, right? Bear with it. 5 open bracket x plus 1. That is the same as 5 times x plus 1 equals the 3 now multiplying by the 2. The 3x multiplied by the 2. Let me know if you all need any assistance with this. Right? 3x times 2. Let's see if we could simplify a little further. 5 times x gives us what? 5 times x is?
5x.
5x. Right? What is 5 times 1 now?
5.
5 equals, what is 2 times 3x?
6x.
6x. Right. Very good. So I'm going to, all we need to do is solve for x. So I'm going to move all my x's to the right side of the thing here. So this 5 is moving across to here. It's positive 5. I'm going to move it. This positive 5x, sorry, is going to relocate itself. So if I move that across there, on the left side, I am just left with positive 5. And on the right side here, I have my 6x. But if I move the 5x across, what does it become?
Minus 5.
Negative.
And what is 6x take away 5x? So we solve for x. Okay? X is equal to 5. All right, we good with this? Right, so functions is easy.
So why would it be 1x?
Sorry, you can put the 1 if you want. Yeah, you could put the 1. That's okay. 1x is
Someone
still,
wanted to know why you cross multiplied.
because that is the only method I know to solve for these. When you have two fractions like this, once you have a fraction on both sides, cross multiplication is the technique of choice to solve for your variables. That is why I cross multiply. Every time you'll ever see me dealing with two fractions, when I'm faced with a fraction being equal to a fraction, I always cross multiply to get it into a form like this below, where we could easily apply these types of moving across variables, etc., to solve for my answer. This cross multiplication helps us to solve very easily and quickly.
Isn't the cross multiply much more easier?
I find so. It may have other methods you could use to solve for x here, but that topic you could do further research on. That topic would be called what? That would be solving linear equations. Because notice this type of equation is called a linear equation. So you could take note of that. I won't go into details right now about why it's called linear, only because of the interest of time, but this is still a linear equation. So I'm going to leave a functions question for you all to try, right? I will leave one for you all to try here, right? And then let me find any question I don't do in this document, I'll post the solutions for. So rest assured. Let me see which question I am moving on to now. And that will be this question. I'm going to move on to question 5. And this particular question 5 is particularly difficult for a lot of students because it's a statistics question, but not that it is a statistics question. It comes in a way that they don't usually test. What they did in this question is they gave you the cumulative frequency curve, and you have to work backwards. Sorry?
Is it like that time slope?
So I didn't hear you. Sorry. I can't hear you.
Sorry, can you continue?
Oh, no problem. Right. So they gave you a cumulative frequency curve, and you have to work backwards and answer questions based on it. And it might seem simple, but mind you, don't underestimate this question. This question is not to be trifled with, right? So let's take our time and dissect this question in the last 20 minutes we have. All right, so before I go into this question, I would like to review, just 1 second, right? I would love to review basic things in statistics. All right, so you all should be, this was another thing I was preparing here. You all should be familiar with how a cumulative frequency curve and stuff looks by now. I'm expecting that students on the verge of writing CSEC should know what a cumulative frequency curve is, and you may have actually drawn cumulative frequency curves in your school, etc., in preparing yourself. Typically, a cumulative frequency curve question comes like this. They give you certain things called intervals, right? And here, now I made up these numbers. This is something I just made up. But let's just look at it quickly. In this particular question, let's look at, I'm going to call this information, this is a table representing the frequency or the number of students who got these particular marks in our exam. So the exam is out of 80, and let's say that 2 students got between 71 and 80, 15 students got between 61 and 70. I'm reading upwards from, let me increase the size of this. 12 students got between 51 and 60. You're kind of seeing what's going on here. 2 students got between 41 and 50. 9 students got between 31 and 40. So that is basically what this table is showing. I don't know if you all are aware that on this column here, the first number is called the, why did I write that? This is wrong. Sorry. In the heat of the moment, I have to swap these words. What is the name given to the smaller number? It would be the lower limit. Do you all know that? Right. So this is the lower limit, and the one on top here would be the upper limit. That is important. Now, have you all ever heard of lower class and upper class boundary in this topic of statistics?
Yes,
Yes.
sir.
Yes, sir.
How do you calculate your lower class boundary?
It is 0.5 below the lower limit.
Excellent. You take your lower limit and you take away 0.5 from it. So if I have 1 and I am to take away 0.5, I will end up with 0.5. If I take 11 and take away 0.5, I will end up with 10.5. 21 take away 0.5 is 20.5. I take away 0.5 from my lower limit. How do I get my upper limit?
It is 0.5 above the upper limit.
Very good. Sorry?
Sorry. So if the lower limit you take 0.5, the upper limit you're going to add the 0.5.
Very good. Yes, you are adding 0.5 to the upper limit to get your upper class boundary. So to get your lower class boundary, you take away 0.5 from your lower limit, and to get your upper class boundary, you add 0.5 to your upper limit. So 10 add 0.5 is 10.5, 20 add 0.5 is 20.5, so on and so forth. So I just wanted to point out this for you. And this is something I want us to do together. Here, this is a frequency table, basically. And I want us to see if you all can remember how to calculate cumulative frequency. Do you all remember how to calculate cumulative frequency using frequency information?
Like 5 plus 6, and then that answer plus 8.
So can we all add this up together for me here? So if it's 5,
First number.
the cumulative frequency here is still going to be 5 because we didn't start to add as yet. But what's your next step? What do we add to get the next value?
The 6 to get 11.
So we take the 5, we add the 6 to the 5, and we get 11. And then we add 8 to the 11, and what do we get?
19.
19. And we add 9 to 19, what do we get?
28.
28.
28.
And then
And we
30
add 2,
plus 30.
30.
42.
Add 12 to 30, what do we get?
42.
We add 15 to 42.
57.
57.
57, right? And then I'm not checking it over. I trust in you guys here. And we add 2 to 57 now, and we get 59. I should have probably put it at 3. Let me make this at 3 now. It's bothering me, right? 3. So it'll become 60.
60.
The 60 students would have written this exam. So this is easy. Everybody agrees? Relatively easy?
Yes, sir.
Now, what trouble starts, sir? And this is what I did this with you for. What if you were only given the cumulative frequencies column here, and I remove some of these numbers? Let's say I were to remove this number here, remove this number here. Can we use this information to figure out these missing numbers?
Yes.
Yes.
Yes, sir.
How do we figure out the missing numbers? And before you answer that, the reason why I'm telling you this is because this is exactly what you're going to do in that next question there. You all understand? This is how they're going to come. They will give you this information, and you will have to work backwards to figure out the missing numbers. So in order to find the missing number, let's say we want to find this number as 8, you need to take away 19 from 11 to get 8. You understand that? Or say 11 plus what number going to give me 19? So that means you're taking away 11 from 19, and you're going to get 8. It is very important to remember what I'm saying here now for this particular question. All right, so let's look at what we could do in this particular question. Right, so we're going to start this question, and that what I've told you about will help us with this portion, part B. But let's look at part A. So in this cumulative frequency curve that they gave us, they want us to use this curve to find an estimate for the number of students who took more than 50 minutes to solve a problem. So if you read the question is actually a cumulative frequency curve that shows information about the times taken by 200 students to solve a maths Olympiad problem. So how do we interpret this curve firstly? Let me tell you how. Let's just pick a random time here, 20 minutes. If I go up from 20 minutes and across, this is like 30 something, right? It could be between 20 and 40. So it could be like 36 something like that. So if I go up from 20 and go across, that just means that 36 students would have finished the exam in 20 minutes. If I go up to 30 minutes now and I go up, around 76 students now would have finished the exam in about 30 minutes. If I go up to 40, I go up, it's even higher. 160 out of the 200 students would have been done with the exam at about 40 minutes. You all kind of get the idea of how we're interpreting this? If you go up to 50, that's up here actually, 50. If you go across, that could be like 190 something students would have done the exam by 50 minutes. Now that making sense. If you start the exam, obviously, as more times goes on, more and more students will finish the exam. So that should not sound too strange. So that's how we read this cumulative frequency curve. So the first question, what is the number of students who took more than 50 minutes to solve the problem? How do we find the number of students who took more than 50 minutes to solve the problem? So we look at 50 here, we scroll up, and we read off the value over here. Now, let's look at something. Let's do it. Now, I wouldn't be able to draw this perfectly, but if we draw this line, this here is the 50 mark, okay? Notice, this is just one below the top. So that will actually correspond to here. You're seeing that? Here. This number, if you look, how do you figure out what is the number where that line is I draw there, that green line? What number does that represent? We have 5 boxes here. 1, 2, 3, 4, 5. Each box would represent how much students?
4.
4 students. So here will be 184, 188, 192. So this line has to be 196. 196. Well, let me just draw that out now. 196. Now, let's listen to the question. They want us to figure out the number of students who took more than 50 minutes. More than 50 minutes. Do you agree, though, that this 196 students would have already finished the exam in the 50 minutes? Think about it, sir. Look at it. There's a trick in this question. This 96 on top here meant that this 196 on top here meant that all of these students below already finished the exam. So if 196 students finished the exam, how much students did not finish the exam?
Make up the 60.
So you would take away the 200 by the 196.
Yes, that is exactly what we're going to be doing. That is the trick here. They want to know how much students took more than the 50 minutes. So we take the total number and take away the number who finished at the 50 minutes mark, which is 196. And the answer is 4 students.
4 students.
Okay? Look at this on your own. You all have time. I'm going to I might finish around 5 minutes past 8. I just want to see how much of this I could get done before we wrap up. So I'm hoping you all could bear with that if you all can. I just want to do some more work on this question as it's fresh in our head. How do we find the median from a cumulative frequency curve? They want us to find the median time. N plus 1 over 2. Very good. N plus 1. Somebody said it. This is the formula for median, right? What is N? N is the total number of students, which is 200. That's what they gave us, right? They gave us 200 students as N. So N plus 1 over 2 will be 200 plus 1 over 2, which is what? 201 over 2, which works out to be around 100.5 students. Now, because it's an estimate we get in here, remember these questions we are estimating, I'm going to just read off the 100 mark. All right, I'm just going to read off the 100 mark. Because it's going to be real hard to estimate that. Because remember, each line represents 4 students. So I'm not going to get 0.5. It's going to be ridiculous. Right? So I'm going to just watch how to do it. You find the 100th student. You draw a line across. That actually draw really good. Right? Just give me a second. I'm going to draw the line down now. You have to draw the line coming down from here. That's here somewhere. And you need to read off what number that is. What number? That is very good. So each one is 1. This is 31, 32, 33, 34, 35, 40. So very good. 33. So the median time works out to be 33 minutes. That's it. These are not difficult concepts, okay? These are using your cumulative frequency curve to answer basic questions. Make sure you can do that. Notice drawing a cumulative frequency curve is not the only thing you need to know to do. You have to be able to use your curve. And that is what they are testing you here. Last question for this part. What is the probability that a student chosen at random took at most 28 minutes to solve the problem? So, you want to figure out what is the formula for probability. You all know what's the probability formula for this question going to look like? There's a formula that you all would probably have encountered for probability. P for probability.
Third.
What is the formula
number of students over 100.
Very good. So we're going to be looking at the number of students over total, not 100, total number of students. Total number of students. So we're looking at the number of students who fit this criteria and divide it by the total number. What was the total number? 200. So 200 is our denominator. We just need to figure out what goes on our numerator. All right, so we just need to figure out what goes on the numerator. So this is what we have to use our curve to find. We have to use our cumulative frequency curve to find the number of students who took at most 28 minutes. So if I look on my graph, I have to find 28 minutes and read off the number of students. So wouldn't 28 be like 2 below 30 there, right? 2 before 30. So if I find that here, let me see if I could draw it. That will go up to here. That's 28. And now I have to draw across and see what that touches. Right, so if I have this line here.
64.
64, excellent. You all saw it. 64 students. Now, remember the little dilemma we had before. Do you agree that at this point here, at this 33-minute mark, we could agree that 64 students would have at least finished the exam? Because remember, everybody finished in the exam as you go up. So this 64 students finished the exam at 33 minutes. So that is the actual number we are going to put in our numerator for this question. 64. So the probability that a student chosen at random would have finished the exam in 33 minutes is the number of students who finished at 33 minutes over the total number of students. So what is 64 over 200 working out to be?
0.32. 0.3 or 8 over 25.
Right, so 0.32 is the probability, or 8 over 25. Okay, this is the answer for this. We have, I'll tell you, just give me 5 minutes again, all right? And we'll, I want to just introduce how to do this last portion of the question here. This is what I've been working towards. Remember the little stuff I draw on this line, on this paper here, and I told you about? That is exactly what we're going to be using here for. Okay? We're going to see it happening here. Let's try to understand what's going on in this table. Using the cumulative frequency curve on page 13, that's the curve we've been looking at, complete this table below. So we have certain times. This is the times the students finished. We have midpoints. We will get to, we don't need it yet, but notice we have a frequency column that is incomplete. Remember, that is what I mentioned to you. That is exactly this. What if we have an incomplete frequency column? Now, what type of curve is the curve that was provided for us? Wasn't that a cumulative frequency curve? So you could actually read off the cumulative frequency values that is for each interval. That might sound confusing, so let me explain something for you. In this particular document that I was working on here, if I wanted to plot this information as a cumulative frequency curve, right, I would do something. Wouldn't I have plotted I would have my axes like that. I would put my cumulative frequency on my y-axis. What would I have put on my x-axis? I could either put my boundary or my upper limit. Actually, it wouldn't matter for this particular question because the numbers are so close to each other. So I could put my upper class boundary or my upper limit. So I'm just going to put limit here, upper limit, right? Upper. Bear with me. I want you all to understand. You to click just now what I'm doing. So let's say we have this curve. You'll see in the curve. Remember in the question, they gave us the upper limits. You're seeing where I'm getting at here now? We know the upper limits. So if we know the upper limit is, let's say, a value, what you have to do is read off that value and figure out the cumulative frequency that corresponds to each upper limit. That is what you have to do in this particular question. So let's look at this particular limit here, right? 10. You're seeing 10 is the upper limit here. This is a hard question, I'm not underselling it. So you're going to look at the 10 in your time and your x-axis and figure out what is the cumulative frequency associated with 10. You would do the same for 20. You would do the same for 30. Let's do it for 20. What would be the cumulative frequency associated with 20 minutes? So all you're going to do is draw your line coming up from 20. That's around here. And you're going to read it across. This value is a cumulative frequency value that corresponds to your 20-minute interval. So what number would this be? This would be around 36. I think this would be around 36. So this is what I would do if I were doing this question now. I know it's a hard concept, but if I were doing this question, you see how over here, I drew this kind of structure here? I would draw this again. Because remember, if you know all the cumulative frequencies, you could easily figure out the missing frequencies. We already established we could do that earlier before we started the question. So I'm going to try to draw one of that right next to this thing here. Watch how it's going to look. I'm going to put my frequency as a column. Because remember, we pull in cumulative frequency values from the curve. So I'm putting my frequency values, and I am going to put cumulative frequency values that I get from the graph for each interval. So notice for frequency, they gave us a few. So we know this one is 12. We don't know this one here. This one is 42. This one is 84. Right? This one we don't know. And this one is 4. Now, in any graph, And you could verify it with this. The first frequency value is always be the first cumulative frequency value. I don't know if you'll ever notice that trend. It always holds. So my first cumulative frequency is going to be 12. Notice my second cumulative frequency value I got when I read it off the graph was 36. So I'm going to put that 36 here. Tell me if you all could figure out what is this missing value. If I know 12, all I need to do to figure out this missing value is a 12 add something is going to give me 36. That is how I could figure out my missing value. Are you understanding what I'm trying to do here? It's a hard question. I'm not going to sit down and say this is an easy question. This is it could be considered a hard question. So, actually just now, would it be 36? It depends on how good you read off this graph, right? So let me just make sure. Right, that's in the middle here. And so if you go up from 20, right, just want to check something here. That's here, right? And if I read across that, right, you will get a value close to that value there. It will probably be around 32, 3, 4, 5, 6, 7, 8, 9, 10, 34. It will be in the middle. So this will be 34 actually. Right? I hope you all could see. When you all do it properly, you will see that's 34. So this is actually 34. 34. So how would we figure out what missing value would be here? This is where we end in the session. After this, you all could probably try the question and we'll correct and we'll finish it next day. 12 add something is going to give me 34. 12 add what is going to give me 34? 12 add 22 is going to give me 34. That means this missing value have to be 22. And the other values is 40. And for these other values, you could read them off your cumulative frequency curve. So if I go to 30, right? If I go to 30, and I read off the value that corresponds to 30, I go all the way up, and I go all the way left. What is the value that corresponds to 30? That is this value here, which is what? 76. So that is what you're doing. So this missing value down here will now be 76. Important, 76. And you keep doing it going down. So for 40, you check what's the cumulative frequency value for 40. And if you want to check over your work, what is 34 add 42? Isn't that going to give us 76? So you can actually double check your work as you're going across. Right? So that is how it is important. You have to go and look for each one of these values. Find them. And then you could figure out the missing frequency numbers. Once you get all your cumulative frequencies, it's easy to figure out your missing frequency values. And that will be basically why this is a difficult question, because you have to work your way backwards, given the graph. So this is where I'm going to stop for today. Tomorrow, we're going to finish out this particular question. I know a lot of you might eagerly want to do some research on this question and make sure you can do it, because it's a harder question that you may not be aware that could be tested. Let this be a guide so that you will have an idea of what to do to get through this particular question. And to get this value, you just multiply these two numbers. Right? And we'll see. You'll see it. We'll finish it out tomorrow, next day.
Yes,
but
sir.
as it stands right now, we are almost finished with. I chose this question, guys, because this is a difficult question. This came in January 2023, and look how they tested this topic of statistics. They didn't give you it as easy as these types where they want you to plot just your cumulative frequency curve. Because I'm pretty sure you all could fill out a table like this easily. You all could generate all the cumulative frequencies easily. You all could plot your graph easily. Most of you would know how to do that. But the problem would lie if you have the cumulative frequency values and you may have to find missing values in your frequency section. That is what this question is tested. That is why this is a good question to practice before tomorrow. So tomorrow when you finish it, right, you will have finished this particular thing. So tomorrow I'm going to do this particular question. I am also moving on to a question 6 because this is a question 5. So we're going to be doing a question 6 tomorrow as well, right? So I'll post this document. You will feel free to start working it. I'll be doing one of these questions tomorrow as well. Right, so you'll take a look at this paper. I'll be posting it. So I hope today was I'm going to save this. I will post it for you now. Do you all want this as class notes? Do you all want
Yes,
this?
please.
Yeah, yeah.
Yes, sir.
I will name it somehow and I will upload it for you, right? I'll upload it for you.